Okay, we are Team 15. I'm Drew Harris.
I'm Farah Borhan.
And I'm Haziq Rahman.
And this is our presentation of Design Phase 2 for the Arduino. Okay, so just a brief introduction here. This Design Phase 2 essentially contained 5 components. We have continued project management. That's just an ongoing process that will continue until the termination of the project. We have considerations for intellectual property rights, where we looked at existing patents that may or may not be related to our product. We also have a product decomposition, where we break down the product into its essential components. And we have a concept generation, where we go through how our BRG essentially was generated and how we selected the certain elements of our BRG that we wanted to include in the final product. And lastly, we have a project investment proposal, and that is proposing an investment for VTEPs to consider for our Arduino.
So next is the project management. As you can see over here, the Gantt chart shows our progress thus far. And comparing to the Gantt chart in DP1, there's nothing changed in terms of the duration and how the Gantt chart flow. So as of for now, we're currently in the process of making the prototype for the final presentation. And if there's no trouble we face during prototyping, the project gonna end as scheduled.
Next is the intellectual property. A patent search was conducted to determine if our design conflicted with the other patent. So this is the summary of the patent search that we have. The first one is the transportable interactive kit. As we can see here, the design claimed this patent claimed that the designs of the housings of the box to store the kit. So it is our limitations for our team to do the design as same as this kit. And the ideas came from this design is the compactness of the kit being arranged in the housing. So the team will take these ideas to implement in our designs. Okay. Next is the head touch. Okay. This patent possesses a great similarity to our design. The key features of this patent is that a sliding support moving along a vertical guide and carrying a contact pillar. It also used an actuator to drive the movable member using an electronic unit, controlled by an electronic unit. So, as a comparison, our design, we use a leaf with string connected to a pulley and a motor to lift our small container up. So, this distinguishes our patents. This distinguishes our kit to this patent. Okay. The ideas that we gain from this patent is that this pillar can be attached and detached from the vertical guide. So we will take the ideas and apply it to our kit.
So after analyzing the information from intellectual property, we proceed with concept generation using the 365 methods. There are 9 solutions in total, and from the 9 solutions, we decided to discard 3 solutions. So the first solution is fan. We decided to eliminate this because the air velocity provided by the fan isn't going to guarantee to provide enough lift force for the ping pong ball. And next is the rotating blade. When using the BRG using this rotating blade, it's going to raise a few safety concerns. So that's why we eliminate this. And then next is spiral tube. Even though it has an aesthetic appeal, we eliminated it because it is hard to construct. As you can see over here, there are 6 combinations of solutions generated, and we proceed with the concept selection using a screening method. In the screening method, there are 2 criteria that plays a huge role in determining which is the best combination solution. And the 2 criteria are low cost and durability. As you can see over here, 4 of these combinations score positive, but PBR and PBC score negative. This is because the conveyor belt used in this combination. So conveyor belt requires multiple Arduino motors. Arduino motors is quite expensive, so that is why it received a negative point in low score. And it also needs heavy maintenance, and that is why the durability of the PBR and PVC receive a negative point. From the selected combination in screening section, we proceed with the scoring process. In scoring process, there are 2 criteria that plays a huge role, which is safety and low cost. STR and STC receive a low rating for safety because it uses a spring shooter. And as for PTR and PTC, we believe that round beam is harder to construct compared to the cone funnel. Thus, the combination that used round beam will receive lower rating compared to the ones that used a cone funnel. So out of these four, we decided to continue our project using the PTC combination, which stands for pulley, tube, and cone funnel.
The next part is the failure mode and effect analysis (FMEA). The team conducted FMEA and this table summarizes our findings. Okay, the majorities of the failure mode lies on the poor support, the connections of the pulley, and the designs of certain parts. For the second failure mode, which is the pulley, it received the highest risk priority number. Okay, the string that attaches the pulley to the motor can be easily detached from its position, thus it received the highest occurrence. Okay. So, the team recommended that we should tighten the connection of the pulley to the motor and run through a series of testing. Next potential failure mode is the tube did not release the ball. So, the potential effects of this failure is the ball will stuck inside the tube. Okay, for the team's design, we have 10 balls inside the tube and the user will manually release the ball one by one according to the desired input. Okay, if the ball fails to be released from the tube, it will fail to demonstrate the concept of additions. Okay, so to address this potential failure mode, the team decided to widen the diameter of the tube to make sure that the balls can be released from the tube.
Okay, so in order to provide VTEPs the complete project proposal, our team developed an investment proposal. You'll see we have 3 columns in our cash flow diagram there on the left, one of which is for VTEP's expected input, that's their investments by quarter. Another column is for the return, that's the expected return to VTEPs for their investment. And the third column is net, that's simply the return minus the investment. The inputs, the expected investments are broken up quarterly, and we have a color scale on those where the darker reds represent the greatest amount of investment, and the darker greens represent the least amount of expected investment per quarter. The investments themselves, we have broken down into 4 categories. We have a $10,000 initial investment for the injection mold that we're going to need to make our project. We also have a $10,000 fixed cost, that's something set by VTEPs at the beginning. We have advertising costs, which are $1,000 per quarter and decreasing linearly to $500 per quarter by the end of the 12th quarter. And we have product development costs at $750 per quarter, and that's simply to keep up with competition and keep improving the Arduino. All of this together yields an APR of 12.8%. That's based on an IRR calculation at 3.2%, which of course is quarterly, so that translates to a 12.8% APR. Alright, so to conclude this Design Phase 2 presentation, just like to briefly go over what we've accomplished thus far in the process. Obviously Design Phase 1, that's complete, and Design Phase 2 is also complete, and within Design Phase 2 we have 5 things we've completed. Project management, that's an ongoing process that's going to continue until the termination of our project. We have gone over patents that look similar to our project. We've decomposed the product, and from that generated concepts, from which we picked one final concept, and we have proposed an investment to VTEPs for our project itself. Looking forward, we have a few minor details to wrap up, and we will then be ready to move forward, hopefully with production, should VTEPs choose to go forward with our project.